And looking at it, I think they're continuing last year's talk, I guess, where we sort of following the cookie trail, right? So that was that was the wrong conference, but at least that was the DEF Conf, but it was still a good talk. So if you didn't watch it yet, I think it's a good, well, probably too late now, but a good preliminary to this talk, I assume. So I guess we're waiting for the slides to pop up, and then you can get started.
Ofproto detrace. Ofproto detrace. Yeah.
Any good jokes before we waiting? All right. Good luck.
So hi everyone. I'm Dumitru. I'm part of the OVN team in Red Hat, and together with me I have Alesh, also in the OVN team. And we're gonna. This is a lightning talk about debugging stuff. We had earlier today we had a talk from Adrian about ofproto trace, live tracing. This is a complementary talk about detrace. So yeah, and what we consider to be the missing link in debugging OVS, at least before OVS 3.4 that was released a while ago. Let's see. Do I need to? Yes. So it's about debugging. Whenever I have to debug something, or we have to debug something that's running OVS, we wonder what's going on with the packets. And if you start at the bottom, if you look at what's going on in the kernel or in the data path, it's not necessarily kernel specific, you see something like this. I'm curious if people will ever wondered, okay, what actually generated this? Why are my packets hitting this in the data path? So yes, what are we gonna talk about today is how to debug this. First, we're gonna show a bit the topology we're trying to debug. It's a simple example, and we're gonna walk up the different layers and make the connection between those, and also showcase the tools that are currently available and actually allow you to link all the layers to simplify your life when debugging. So from a kernel perspective, or from a data path perspective, this slide is kind of inaccurate. It's not necessarily only kernel, it's data path, obvious data path in general. The topology looks like this. Our topology, the one we're debugging, looks like this. We have two nodes connected through a Geneve tunnel. They run the obvious data path, which contains flows. And we have a client VIF and a server VIF, one on the left side, one on the right side. So in the kernel, the networking, the virtual networking is implemented through a data path flow table. Most of the people here probably know what that is. It's just flows with matches. Matches can be packet fields, contract states, ingress ports, recirculation IDs, etc. And actions, drop outputs, send to contract, change packet fields, etc. But what's important is that these flows have a UFID, a unique flow identifier. And that's the mapping between the kernel data path flow and what created it in user space. I said kernel again. It's not necessarily only kernel. Oh, no, this doesn't work. This should work. Okay, so if we focus a bit on the dump that I had in the first slide, we have here two flows. We can see the first one has recirculation ID 0, so that means our packet is hitting that one first. It's coming from a client port. We can see the source IP, destination IP. We see that it goes to contract, and then when it comes back from contract, it's going to hit the second flow, recirculation ID 25. We can tell that the contract state is established, so it's part of a session that was established before. We see that well, we don't see it here. Oh yeah, we see it. The destination IP changed, so NAT happened. We see that TTL changed, so routing happened, and so on. So that's all useful, but we still don't really understand why that happened. And assuming that the behavior we're seeing is not what we expect, that's not enough information. So before we try to explain, we try to debug further, let's have a look at the open flow view. So this is just above the data path. It's essentially the same picture. We have two nodes, two OVS bridges on each node, our client and server VIFs connected through OVS ports to the bridges. And on the bridges this time, we have rules. We have open flow rules. And these are similar to the data path flow rules. They have priorities, matches, actions, but most importantly, they have a cookie, which OVN controller uses to embed hints that will point us back to the source variable that yeah. Oh, here's sure. VS3. Yeah, the new what it puts flow contribution and the run is the actually PM kind of if you're it's the same it's deep this I mix them.
For folks online, we're just having a technical issue, trying to resolve it.
Continue, hopefully soon.
Is the audio good now? Let's see. No. Okay. Yeah, so this was our OVN topology. I'm not going to explain it again. We have two nodes, switches, routers, a load balancer, and traffic going from client to server through that load balancer. So if we take the tool, so if we take the new ofproto detrace and we call it on one of the flows we got in our data path flow dump, what we see is going to be a set of open flow rules. In this case, we selected a couple. We look at the fees. That means the load has no it registers the watch where the cookie to actually get the information we need from the southbound database. So we can list records from the southbound database using the cookie value because the cookie is actually the first part of the UID in the southbound database. So in our case, the green cookie corresponds to a port binding. So that flow was generated because we have a client logical port with those MAC addresses and so on. The red cookie corresponds to a logical flow created by OVN that in this case does load balancing. And we can go further. In the southbound database, OVN North T also adds hints. They're called stage hints. So we actually have a mapping from the southbound to the northbound database. For ports, it's kind of one-to-one. Port binding and logical ports have the same name, so that's easy. But for logical flows, we need that stage hint to figure out the northbound entity that created the flow. So if we look again at that red cookie / UID, well, in this case, it's the hint. We see that it's actually a UID of a load balancer configured by the CMS in the northbound database. So that's why our packet was hitting that flow. So like this, we created we actually managed to figure out the link between data path, open flow, OVN southbound, OVN northbound. Click, yes. And I did manually through the slides, but we also have OVN detrace, which is an OVN tool. And this one does all the decoding for you. It was originally intended for ofproto trace outputs, but it just works out of the box with ofproto detrace. So what you can do is dump your flows, get a UFID, pipe the output, call ofproto detrace, pipe the output of OVN detrace, and you get logical flows, load balancers directly from your data path. So yeah, we don't have a fancy demo, but we have more slides. So I'll let Aleš take over.
Yeah, I'll try to be quick. So this is just how to put all those information together. So we will start with the data path flow. As you can see, we have the recirculation ID, ingress port. That's basically what the data path flow would look like with some matches and some actions. Yeah, sorry, this is the that was the packet. This is the data path flow. So yeah, we have some matches, some actions, and more importantly, we have the UFID. So we can take the UFID, do the ofproto detrace, get the open flow rules. From there, we could, as what said, OVN detrace does a good job, so you don't have to scramble it or decipher it yourself. You can just basically pipe the output directly into it. But in case you want to go through that route, so you can take a look at the open flow rule, take a look at the cookie. You will find some corresponding cookie in the southbound database. In this case, it is the open flow. It is the logical flow that we have mentioned. Here we have the stage hint, which maps to the northbound database. So that's basically it. What's the key takeaway from this? So there are no mysteries. It might look complex and scary, but yeah, now with the tools that we have mentioned, you can really get what you are looking for pretty quickly. I mean, there are some caveats in that, and some flows are harder to trace. For example, if you are going through controller action and things like that, this is really tedious to trace, even with the tools that we have currently. But still, for most of the stuff, good enough, I would say. At least for us, we are able to debug complex stuff and get something meaningful out of it. So I think, yeah, I think that's about it, right? Yeah, that's all.
All right, thank you. So we have 2 minutes left, and then our break is over. So if anyone has any question, we skip the break in total. Yeah.
In dump flows with -m output, right? The CT state was a X number, not actually expanded to plus new, plus track, whatever it was, right? But if I use, I forget the name, I was trying to find minus no names or minus names, then the CT state hex number gets expanded to the actual thing. Is there a way in which by default we expand the CT state from X to the actual values? Otherwise, it's very hard to debug.
I think you can send the patch upstream to get that out. Yeah. All right. One final question.
Thank you. So the cookie is the beginning of the UUID. Is there a way to tell in which table the UUID is relevant?
Well, kind of. I mean, if you look at the various stages based on the table ID of the OpenFlow rule, you should be able to match where it lands. Most of the stuff in the pipeline are logical flows. But yeah, I'm not sure if you have any other hint.
Yeah.
Okay.
Use OVM detrace, please.
Right.
It will do that for you. It will try all the tables until you get the ones that have
Okay. Thank you.
relevance. Yeah.
All right. Thanks to the speakers one more time.